Hey everyone, Mr. Newman here. We're going to make a pretty quick video. I just want to show you guys a way to solve finding an exponential graph if you have two equations. So first of all, you know it's an exponential graph, and they also want it in the form a times b to the x. So let's take, for example, let's say your 2 points are 0, 1 and 3, 8. One interesting fact is 2 points define a line. 2 points do not define an exponential function necessarily. But if you know it's an exponential function, then 2 points define a specific exponential function. Let me show you what that means in terms of this formula right here, because you notice we're not moving the function up, down, left, or right, etc. So what I'm going to use, I'm going to use the input and output. 0 is the input, 1 is the output. So I know that x is 0, y is 1, and 1 equals a times b to the 0. I can also use the other point to rewrite use the same function, but different inputs and outputs. So 3 is the input and 8 is the output. 8 equals a times b to the third power. So those a's and b's right there, those are the same a's and b's. So we have a system of equations now. First of all, 1 equals a times b to the 0. Well, b to the 0 is just 1, so I know that a is 1. That doesn't always happen nicely like that, but sometimes it does. And so what I can do is I can take my equation on the second line, and I can substitute 1 in for a, and now I can just solve for b. A lot of students get mixed up here because we've just been doing logs and try to rewrite it as a logarithm, and they forget, oh, to undo a cube, we need to use the cube root. So cube root both sides, and b is equal to 2. So our function is 1 times 2 to the x. You could omit the 1, and that would be perfectly fine just writing 2 to the x, and I think I'd do that later in a later function. All right, let's try that again. Let's make it a little more difficult. This time, input is 1 and the output is 1/3. Make sure you don't mix up your x and your y. That's another common mistake. I'm going to solve for a. So I'm going to divide both sides by b. And when I divide by b, the b's divide out, so I get 1 over 3b. If you're not sure why those fractions are 1 over 3 divided by b becomes 1 over 3b, just remember that dividing is the same as multiplying by the reciprocal when it comes to fractions. So I've solved for a. Let's take the second point and get a new equation there. It's nice that we can't mix up x and y because they're the same. So I'm going to rewrite that, but instead of a, I'm going to substitute in the expression that I solved for a equal to. So 1 over 3b is equal to a, so I'm going to substitute that in for a, and we get 1 over 3b times b cubed. Well, the b cubed and the divides out with the b, so we get 1/3 b squared. Oftentimes when you substitute and solve for a, I find that the b's, there will be different powers, and you'll see this in probably, I think, the last problem on this page, but there will be different powers, and they will divide out to give you just b to a power. So here it's b squared. Let's multiply and solve for b. So we get 9 equals b squared, and 3 is equal to b. Just a quick side note, you could check your work, and you might wonder, what about -3 as a possible b power? Actually, I don't know if you guys remember, we did notes on this. The reason b cannot be negative is because in exponential functions, a negative power raised to a decimal does not exist. A fraction that is not there's a it's a negative power raised to an x value does not look pretty on a graph because only certain values can be in that exponent. So sorry that the b must be positive there, but it is good to consider that. All right, so let's rewrite. So let's figure out what a has to be equal to. We could put in any of these functions or any of these equations, but I'm going to choose this one because I've already solved for a. And we plug in 3 there, and we get a is 1/9. So our final function is 1/9 times 3 to the x. All right, let's try the next one. These 2 points are now 0, 1. So once again, look what happens. A is 1, but I chose this problem because now it's not a nice, pretty solution. What you'll usually see is this as a non-calculator problem. So notice what I had to do. We're going to have to take the 4th root of 12, and I can't do that by hand, so I'm going to leave it as the 4th root of 12. That's actually the exact answer. If you plug it in for a decimal, you get a rounded or approximate answer, and the exact answer is the best way to write that there. So our equation, since a is 1, our function is the 4th root of 12 to the x power. So I want you to try that last one on your own. It will be another pretty ugly one, as far as you'll want to leave it unsimplified, or don't type it in and get a decimal. But I think you guys can do that. So thank you for watching.